Hey, welcome to week 2. Today we're going to go through an exploratory data analysis in R. So we're actually going to be using R and we'll make a plot, we'll make a map, we'll go through some sea mammal data, clean it up a little bit, just to give you guys a sense of where we're going and what you'll be able to do by the end of the course. And hopefully this will be a little more interesting than file navigation. And once you get to this page, you'll click on this little code button, download the zip. And that'll download a compressed file. I'm going to put it on my desktop. And then on a Mac, you can just click right here and it will unzip it onto whatever location you saved it on. If you're on Windows, you're going to have to extract all of the files. It should be an option in your Explorer, and you can just choose the location to extract the files to. All right, so let's bring up the desktop. And here's my folder. If you double click this R project file, it'll open the RStudio project directly. And we will blow this text up a little bit so that it's a little easier to see. All right, so just like we talked about last week with the project-oriented workflow, we are now in our project working directory. This is the absolute path for where we are on my computer. And everything is going to, when we are working with files in this repository, we'll be using relative paths. Okay, so if you go in, if you want to just see what's here, there's a data directory with our dive log from last week and a new CSV called sea mammals. And this is just some sea mammal data from aerial surveys taken in, I believe, the Pacific Northwest. I will send a link to the data source, and I have actually subsetted the data already. It was a pretty big file and I wanted something small for us to work with. So this is already subset, and then we're going to do a little bit more cleaning in addition to that. So that's the data directory. In the docs, you'll find all of the weekly resources. And in the R, this is where we have all of our R scripts. So there's a couple of sample R scripts in here already, and we're going to create another one. So we'll go up here, hit a new file, and let's get to scripting. All right, so we'll lower these down. That's how I like my RStudio desktop to look. And always good to start with the comment or title for the script. This is going to be demo exploratory data analysis. And exploratory data analysis, or EDA, is just sort of your first look at a data set, kind of getting a feel for it and what's there, checking out to see if there's any errors, some very light QA/QC. And we'll do a timestamp. Again, that's just TS tab. Okay, let's get the data. And this is just a habit or shorthand from my programming classes in grad school. I tend to call my data D. You can call it whatever you like. Right now what we're doing is we're going to save our the data that's in that CSV to an object called D. So we hit D equals .csv, and then we'll navigate to it using our file paths. If we hit tab, we know it's in the data directory, and it's in sea mammals. Okay, so now when I run that line of code, we should now see an object called D in our environment. And you can see it's 320 observations of 8 variables. So that means that there's 320 rows and 8 columns. There's a few different ways to take a look at that now that it's in our workspace. You could just type D if you wanted to see the whole thing. Let's see, 320 observations. I don't think it's going to be able to preview the whole thing, but let's see what happens. So running that had it print the whole object in our console, and then after a certain point it reaches the max and it's saying it omitted 195 rows. It didn't want to print the whole thing. So if there's no way to look at it conveniently as a whole in your console, there are a few better ways to do it. So one that I use quite a bit is head, and that's just going to show you the first 6 rows of your data. So you can see we've got a weird column called X here. We've got flight number, date, time, latitude, longitude, species, and group size. All right, so that just shows us a little snippet of our data. Another way to look at or find out more about the structure of your data is to actually use the function called structure. So we'll go str, which is short for structure of D. And now we're seeing that the structure of the object D is a data frame. So that's the class or the type of the object. It's 320 rows of 8 columns. And then it shows you the 8 columns below and their title, or what they're called. And then it also has this additional information. So each row here is an entry for the column, which is a little confusing there. But it's saying that this first column X is a vector of type int, or integer. So these are integers. The flight number column is also an integer column. The date, it's saying, is CHR, that's short for character. So it's saying that the date column has information of the type character. So, and then the same for the time. The time column has the character strings in it. Latitude is numeric. So the difference between integer and numeric is that numeric has decimal places. And same with longitude. And then species is a character column with character strings in it. And then group size is an integer column. So the structure just gives you a little bit more detailed information about what kinds of data is in each column. So that's the structure function. All of the work in R is done by functions. So you're going to learn a lot of them pretty quickly here. And then you'll start to figure out which ones are your favorite for viewing data. So for example, another one is the view function. So if view, unlike these other functions, has a capital V, if you use a lowercase v, it's going to say there's no function called view because R is case sensitive. So view is one of the few functions in base R that requires a capital. So if we run that, this is going to be more like a typical spreadsheet view of your data. And it's just going to open a little preview of what that data looks like. And especially in the beginning, a lot of people might be more comfortable with this view of their data than like the view that you get in the console from using head. So that's one option. And another way to get to that is to just open your environment and click the grid icon here, and that brings that up. It's the same as calling view. And in fact, it even runs the code in your console that you can see. Okay. So that's a few different ways to get a first look at your data. But maybe besides just looking at the data, we actually want to get a little bit of summarized information about it. One pretty handy function for that is table. So let's say I want to know how many observations are associated with each species. And that's going to give me 2 pieces of info right off the bat. I'll know how many different species there are and how many observations are associated with each species in this data frame. So we'll do table of D and then $sign to choose the column that you want to summarize. Sorry guys, you're going to hear my 2-year-old in the background. Okay. And we'll go down to species and run this line of code, and that's going to give us a table of how many observations are associated with each species. So we have 123 rows that have fin whale in the species column, and 3 rows that have sea otter in the species column, 146 rows that have humpback whale, and 4 rows that have killer whales, and 44 rows associated with walrus. You could also do table of any of the other columns. Let's do flight number. So now on the top row, these are all the flight numbers that are represented in the data, and these are the number of rows associated with each flight number. So there's a single row for flight number 36, and there are 9 rows with flight number 1. Okay, so now we have a sense of what the data are and what's in it. I think it's time to clean it up a little bit. So one thing I noticed about the column names is that they're not consistent. Some are in all caps and some are in lowercase or have a capital. And when I'm typing, I don't really like working with caps because it's just an extra keystroke and it starts getting annoying after a while. So I'm going to change all of the column names to lowercase, and I'm also going to remove that first column, the X column that I don't need. So to do that, let's see, this is going to be a new part of our script. We'll say data cleaning. To get rid of that first column, we're going to say D, and then I'm going to open a bracket and type a space, comma, -1. Don't worry about what this is doing, or don't worry too much about what this is doing yet. We're going to go on a deep dive in indexing, but just know that this is the code that is going to remove that first column of the data frame. And so if I ran that alone, it's going to spit out the results of that line, and the results of that line is the data frame itself, but with that first column removed. So now instead of seeing X, we just see it start with flight number, and that's what I want. So I'm going to save it over the original object, and now the object D is the same data frame we had before, but with that first column removed. Okay, now I'm going to fix the column names. And to do that, I'm going to first create a vector of new column names. So I'm going to call it lowercase, and I'm going to use the function toLower, which just takes uppercase letters and brings them to lowercase. And say toLower column names of D. And I'm nesting a couple of functions together here. So if I just ran column names D, we'd see the column names of the current data frame. If I just ran toLower of those column names, we'll see all of those column names going to lowercase. And now I'm going to save all of those lowercase column names to an object called lowercase. Now if I type lowercase in the console, we get back that vector of lowercase column names. All right, so now we want to assign these lowercase column names to the data frame. So we want to overwrite the current column names. So to do that, we're going to say column names of D are going to be equal to lowercase, and that is going to overwrite the current column names of D and set them equal to lowercase. So now if we go over here and hit head D, we see that all of the column names have been changed to lowercase, which is great. Just a keyboard shortcut in RStudio to move the cursor between the console and the source pane. It's Control-1 and Control-2. Control-1 moves it over to the source pane. Control-2 moves it back over to the console. This is handy because when I tend to examine things a lot using head or tail. So tail just because, or just like head shows the first 6 rows of a data frame, tail shows the last 6 rows of a data frame. I use head and tail a lot, I use structure a lot, and I don't really want to clutter up my scripts with those calls. So I'll move over to the console with Control-2 and type them there so that they're not saved in my script, or I don't have to go back and delete them later. Okay, so column names are fixed. What else would be nice to fix about this data? Well, one thing I noticed is that the date is in a super inconvenient format. So I don't often use the format day-month abbreviation short year abbreviation. Let's put those into a more standard ISO date format. And this is just going to give you the briefest of previews into the craziness that is dates and times in R. And so we're not going to go too much into details. I'm just going to go through this to fix the date formats pretty quickly here. So next we'll do fix date format. I'm going to call out that date column just like we did above with the species column. And I'm going to save over it with a new format. So I'm going to use the function as date. And I also need to use the function strip time. And again, don't worry too much about the particulars of this yet. I'm just going to, the goal here is just exposure to a typical scripting workflow and some of the functions that you're going to be becoming familiar with later. So I'm going to format that date column, and the format that it's in now so that it understands what it's looking at is its day and a month abbreviation and a 2-digit year. All right, so that's telling R what format the data is in now, and this asDate function is telling it what format I want it to go to. So if I run this line of code, now let's look at what the date column looks like now. So before it looked like this. I've already saved over it with the last line of code, so it should be in a new format now. Just like you can look at the head of a data frame, you can also just look at the head of a column. So I'm going to look at the head of our new column, and it did format it into a better thing to work with. So we've got the year with a 4-digit year dash month dash day. So that's much better. We like that. Okay. So let's get into some plotting next. So I'm going to load the ggplot2 package. I'm going to do that with a library call. And we'll start a new section of the script here. And I'm going to use the function ggplot to start building up a plot. And we're going to do a whole section on plotting. So again, don't worry about what the code is actually doing in this video. We're just going to get some exposure and familiarity with some things that we'll be working with later. So the first plot that we're going to make is, let's say we want to see group size as a function of species. So this code is putting species on the x-axis and group size on the y. And I'm going to make a jitter plot, so basically a scatter plot. And I'm going to color the points according to species. I'm going to make them a little more transparent, and let's start with that. So now we should see this plot pop up in our plot window. You can hit the zoom button to see a little bigger version of it. And this is our data. We've got species on the x-axis, so it's grouped them by species. We only have 3 observations for sea otter, which we remember from our table call earlier. Group size is on the y-axis, so we see that the bigger groups are the fin whales, the humpback whales. We have a big group of over 35 humpback whales. That must have been really cool to see from an airplane. And a few groups of killer whales, and some bigger groups of walrus too. So this is just a first pass at a plot. We can customize it a little bit if we want to see, for example, bigger dots. And since we already have the species spelled out on the x-axis, it doesn't make a ton of sense to have a legend as well. So remove that legend. And the jitter plots are a little wide, so let's adjust the width of that spread of points down to something less. You might want to run this again, see if we get a different arrangement of jitters so that you can see those 3 actual sea otter plots. And okay, so that's a good first exploratory plot. We have location data in this data set. So we have latitude and longitude. One really quick and dirty way to visualize that might just be to put it on a scatter plot. So we'll put longitude on the x-axis and latitude on the y-axis. And we'll add points. We run that. We see our observations plotted by latitude and longitude. So that's a really quick way to do it, but obviously it would be very nice if we had a base map so we could actually see where in the world these points are. And a really quick way to do that is with the leaflet package. So I'm going to load the leaflet package. If you don't already have it installed, you would have to install it. Leaflet is pretty good about recognizing latitude and longitude columns, so let's just make a quick plot. I'm going to be using a piping function. We'll be going into piping during the data wrangling video. I'm going to use the function add tiles to add that base map. Let's see what that gives us. So now we have a base map of the world, and when we add our points, it should zoom in on those. So we'll add our points, and we'll make them reasonably sized here. So when we run that, we get a very quick map of our data points. So these are all of the data observations, and obviously we could customize this further. We could make the circles colored according to species. But again, this is just exploratory data analysis. We're doing this pretty quickly. We're mostly just looking for weird stuff in the data, something that's not supposed to be there. But that looks pretty good, and this is where it is. These were all of those those sea mammal observations were made. It looks like off the coast of Alaska. And now the last thing to do is to clean up the script a little bit so that it follows best practice, and it will be a little easier for other people to use if you want to transfer it. So one of the first things that I would do is move these library calls up to the top so that they're loaded ahead of time. So that whoever is working with this can see immediately the packages that they're going to need to do this analysis. And if they don't have those packages, they can go over and install them with install.packages, ggplot2, or install.packages leaflet. And note that even though you don't have to have these in quotes on your library calls, you will have to have the package name in quotes for your install packages calls. Okay, but it doesn't matter for the library call. You can do either one. And what else would we do here? I might add a comment, inspect data. I might comment out this view line just because it can be sort of surprising if you're working through somebody's code really quickly to have that view pop up when you're not ready for it. Okay, and then let's see what else we can do. We might add some formatting here. I have this comment and separator mapped to a snippet. I'll be showing you how to do that in a different post. I might title this plot. And title this section. Okay, let me save that script for sea mammal PDA for exploratory data analysis. Put that in the scripts folder, and now we've just went through our first R script. So that's it for today. Hopefully that got you guys a little bit more excited about where we're going. I'm excited to make more maps and plots with you as we go on, and I'll see you a little bit later this week with some more in-depth instruction on data structures and data frames and how the functions that we used in this script are doing the things that they're doing. Okay, thanks for watching. I will post the exercises in a link in the description, and I'll see you for the next video.